All right, guys, chapter 2, problem number 3. All right, chemistry fans, welcome back to the Chemistry 1032 problem solving set. Now we're going to talk about measured or exact numbers. So first, a quick definition. An exact number is a number that you can count. For example, how many people are in your family? You just count them up. That's how many people you have in your family. How many bicycles do you own? Just count them. You can count them. They're right there. You can look at them. An exact number is also a number that's defined. For example, we know that there are 60 minutes in an hour. That's an exact number because it's been defined to be that. Measured numbers are numbers that you actually have to measure. You have to take a device like a ruler or a scale, and you have to get a measurement for that. Now, it's not exact because you don't actually say, for example, you weigh 142 pounds. You're probably not exactly 142 pounds. You're probably 142 pounds and 2 ounces. See the difference? So that's a measurement. And an exact number is a number you can count or a number that you can define. So let's look at this problem set. Are the following measured or exact numbers? Okay, so let's look at number 1 on the list. 12 coins. Say 12 quarters, for example. Well, you could count those. You just 1, 2, 3, 4, 5, all the way to 12. So you can count the coins that are in your piggy bank or in your pocket. So that is actually an exact number. Because you can literally just count those coins. You don't need a device to measure them. All right, next question. 10 millimeters and 1 centimeter. Well, a centimeter is defined to be 10 millimeters. And 10 millimeters is defined to be 1 centimeter. So this is an exact number. Okay? We didn't need a ruler to figure that out. That's a definition. That's been defined to be that way. Next one, 4.56 centimeters. Now, to measure, say, for example, the length of a line, 4.56 centimeters, you had to use a ruler to do that. You needed a measuring device. So this is actually a measured number. Because we needed a device to get that number. This one, the next one on the list, is a little bit tricky. 946 milliliters equals 1 quart. Now your first instinct may be to say this is an exact number because a quart is defined to be 946 milliliters. But you have to be careful with this. This quart, that's actually an English or an American unit of measurement. Quarts, gallons, miles, all that kind of stuff. Those are English or American units. Milliliter is a metric unit. So when you're converting or when you have an equality from metric, milliliters, to an English or an American unit, quarts, those numbers are actually measured. They're not exact. So a quart is not defined to be 946 milliliters. A quart is measured to be 946 milliliters. A general rule that you can remember is that if you're working inside of one system of measurement, say the metric system, these are always exact. Millimeters to centimeters, so it's metric to metric. These are always exact. Metric to English or English to metric are almost always measured. There's a few exceptions that we'll get to later on, but they're almost always measured. All right, last one. You're driving home 61 miles per hour. Well, you know yourself when you're driving home, you look at your speedometer in your car. Your speedometer is a measuring device. It's measuring how fast you're going. So your measuring device is telling you that you're going 61 miles per hour. So that is a measured value, a measured number, because you needed a device to tell you. You couldn't count it, nor was it defined. All right? Well, I hope that was helpful. If you're still a little bit confused between exact and measured numbers, please contact one of the tutors here at the Academic Success Center or go visit your professor in the office. And I certainly hope this was helpful. So good luck and good chemistry.